Hello everyone, welcome back to our channel Problematical. Today we'll discuss miscellaneous examples from sets chapter 1, class 11th maths NCERT. 28th question. Show that the set of letters needed to spell cataract and the set of letters needed to spell track are equal. Now, set of letters means here these letters can be represented in the form of sets, or we have to consider two sets x and y, calculate their values, and then show that both the sets are equal. Let A be the set of letters in cataract. Therefore, you can write A as all the letters which are involved in this. Now, A is repeated. A is repeated over here and here. So we'll write A only once. T is also repeated and C is repeated. So repetition words will be written only once. T and next unique word is R. This is your 1. Let B be the set of letters in tract. Therefore, B will be equal to, again T is repeated, we'll write it only once, T R A C, T A R C. Here, as you can see, these letters are same, C, A, T, R, and both A and B have 4 elements each. So from 1 and 2, set A is equals to set B. Therefore, the set of letters in cataract and track are equal. Next, list all the subsets of the set -1, 0, and 1. You have to list all the subsets. So let's just start writing. We know that phi is a subset of any set. So if this is a set, so phi will also be always a subset. Will be a subset of -1, 0, and 1. Next, singleton sets, set of -1, 0, or 1. 3 elements, so 3 singleton sets. Fourth, double sets or 2 elements out of these 3. So that can be 3 combinations of these two of any 2 elements. Eighth, a set is a subset of itself. So if there are 3 elements, we know that there are 2 to the power 3, which is 8 sets, and these all are subsets of set -1, 0, and 1. Next, show that A union B is equals to A intersection B implies that A is equals to B. Now we know that A is equals to B when A is a subset of B and B is a subset of A. This is what we know. So to prove that A is equals to B, we have to prove that A is a subset of B and B is a subset of A. One approach. What is given to you? You have shown that this implies A is equals to B, which means the left hand side of the implies word is part or condition is given to you. So given us A union B is equals to A intersection B. This means let us to prove that your first part would be to prove A is a subset of B. To prove this, let's consider an element in A. Let X belongs to A. That means we have considered an element in A. Now, in any particular set or combination of sets, let's consider an Venn diagram. If you have a set A and if you have a set B. So if you have a set A, X over here or over here, then this element, if it belongs to set A, that element will also belong to set A union B. That same element can also be said to belong to A union B. And question we've given that A union B is A intersection B. So here X belongs to A intersection B as well. If any element, if X is over here and it is in A intersection B, then this element is a part of A as well as B. That means this X now can be said to belong to B based on this condition. Now you were able to write this from this because it was given, and you were able to write this from this because it's basic observation. If any element is belonging to both the sets, only then it will be included in A intersection B. So you started in element X, which belongs to A, and you ended up with saying that the same element X now belongs to B as well. So from this condition, we can say that A is a subset of B because X can hold any value in A. X can hold any element of A. So all the elements of A also belongs to B. Therefore, A is a subset of B. Now let's consider another element, but now in set B. Now we'll prove the second part. B is a subset of A. Second part, to prove B is a subset of A. Now to prove this, let Y belongs to B. And Y belongs to B, then Y also will belong to B union A or A union B. Then we know that A union B is A intersection B. So Y also belongs to A intersection B, given. If this is true, then Y will also belong to A because it's part of both A and B. Therefore, we can say that B is a subset of A because every element of B ultimately is present in A as well. From equations 1 and 2 and 3, we can say that A is equals to B. Next, for any sets A and B, show that power set of A intersection B is equals to power set of A intersection power set of B. Now we know that if we need to prove something is equals to something else, so left hand side should be a subset of right hand side and right hand side should be a subset of left hand side. So let's prove that left hand side is a subset of right hand side. We'll have to consider an element in power set of A intersection B. Now power set is a set of other sets. So let us consider an element in element which belongs to power set of A intersection B. Now we've considered the capital X because capital X represents any set which is a part of this particular power set of A intersection B. X is an element of power set of A intersection B, but in itself, in its own definition, X is not a numerical value or an ordered pair. X is a set. If you have an element of power set of A intersection B, then you can say that X is a subset of A intersection B. Now power set is a set of subsets, which means that in the subset, you will also have A intersection B as one of its elements. Also, X belongs to this. X is a part of this. X is a subset. X belongs to the set of subsets. So X is a subset of A intersection B. Only then it will be a part of power set of A intersection B. So you can say that X is a subset of A intersection B. If X is a subset of A intersection B, in words, it can be written as X is a subset of A and X is a subset of B. Because intersection is written as A and B and. If this is true, then you can say that if X is a subset of A, you can say that X belongs to power set of A. X will be an element in power set of A. And X will be element of power set of B. Now writing this in mathematical form, you can write that X belongs to power set of A intersection power set of B, because and is intersection. We started with X belonging to power set of A intersection B, and then you ended up with X belonging to power set of A intersection power set of B, which means we can say that power set of A intersection B is a subset of power set of A intersection power set of B. This is equation 1. That means you've proven that left-hand side is a subset of this right-hand side. Now let's consider the other way around. Let's take an element in which belongs to power set of A, your right-hand side, intersection power set of B. By writing this as words, we can write that Y belongs to power set of A, intersection is and Y belongs to power set of B. This means that Y should be a subset of A and Y should also be a subset of B. If this is true, then Y should be a subset of A intersection B. Again, if Y is a subset, then Y will definitely be an element of power set of A intersection B. Right? So, if you started with Y belonging to power set of A intersection B, power set of B, and you ended up with Y belonging to power set of A intersection B, which means that power set of A intersection power set of B is a subset of power set of A intersection B. This is 2. From 1 and 2, we can easily say that power set of A intersection B is equals to power set of A intersection power set of B. Next. A market research work conducted a survey of 1,000 consumers and reported that 720 consumers like product A, 450 like product B. What is the least number that must like both the products? Now, excuse me. So, Power reported that 720 consumers like product A. Let N of A be the number of consumers who like product A, is equals to 720, and B be the number of consumers who like product B. This is equals to 450. Market survey conducted a survey of 1,000 consumers. We don't know that whether all the consumers consumed product A and B, or either one of A and B. Hence, for the time being, we consider this as a universal set with 1,000 as the number of universal set value. Now you have to find the least number that must like both the products. Now both the products will be liked by A intersection B. Okay, so you have to find the minimum value or least value of this. In a generalized scenario, we know the formula. We know that N of A union B is equals to N of A plus N of B minus N of A intersection B. What does this mean? This means that if you keep N of A and N of B constant, let this be, let's take another example, this be 20 and this be 30. This is fixed. Here also it's 20 and 30. Here also it's 20 and 30. And let's have different values for these two values. So let's say you have N of A intersection B as 10. Then this value will be 40. If you keep on decreasing this value, let this value be 8. This will be 42. Decrease it by 2 further, 6. You have 44. So what is happening over here? As this value, N of A intersection B decreases, this value increases. So we can say that N of A union B is inversely proportional to N of A intersection B. You need the least value of this. So you need to place the maximum value of N of A union B to get the least value of N of A intersection B. Amongst these values, 40, 42, and 44, 44 is the maximum, and you get the minimum value of A intersection B over here. Now, to calculate maximum value of A in union B, we know that if you draw a Venn diagram, and if you have two values, A and B, A union B will be defined as this portion, and this is U. The maximum these circles can expand, and the maximum, if you want to increase A union B, you'll have to increase sets A and B. the maximum you can expand is cover the whole universal set, because you cannot go beyond the universal set. So maximum value of n of A union B will be equals to n of U, which is equals to 1000. Now place this in this formula. Therefore, 1000 is equals to n of A 720 plus n of B 450 minus n of A intersection B, which is the least value that you should get. So n of A intersection B will be equals to, this is 1170 minus 1000, which is equals to 170. This is the minimum number of people who like products A and B. Next, out of 500 car owners investigated, 400 owned car A and 200 owned car B. Hold on. In the previous question, we wrote is equals to 170. This is the minimum value. What is the least number that must like both the products? So 120 is the least, 170 is the least number to like both products, A and B. Also, if you want to calculate the true value of n of A intersection B, you can write this as, in reality, it is greater than equals to 170. So 170 is the minimum value, but n of A intersection B will be either 170 or any value greater than that. Out of 500 car owners investigated, 400 owned car A, 200 owned car B, 50 owned car A and B both. Is this data correct? Now, out of, it's written that out of, that means all, we are considering that all the car owners owned either of the two cars A and B. So n of A union B is given to be as 500, n of A is given as 400, n of B is given as 200, and both A and B means n of A intersection B is equals to 50. If this be the case, then you have to check the data. Now we have a formula for this. N of A union B is equals to n of A plus n of B minus n of A intersection B. What you're going to do is, you will try and calculate A union B from this formula. That means you will assume that A union B is not given, and you will try to calculate from the RHS A union B. So placing the other values on the RHS, we have something like this. This is 600 minus 50, which is equals to 550. So from your calculation, your n of A union B comes around to be 550. But this is not equal to the given data, which is equals to 500. So from 1 and 2, the given data is incorrect. Next, a college awarded 37 medals for football, 15 for basketball, 20 for cricket. If these medals went to a total of 58 men and only 3 men got medals in all 3 sports, how many received medals in exactly 2 of the 3 sports? So let's draw a Venn diagram for the given data. There are 3 sports involved, and all the medals are distributed in either of the 3 sports. So, A for football, B for basketball, C for cricket. College awarded 38 medals for football. That means in this circle of football, 38 medals should be present. Now, this circle is overlapped by other circles as well. So let's name each region by a variable. From the given data, 38 medals were given for football, and football contains the 4 variables A, B, E, and D. So you can see that A plus B plus D plus E is equals to 38. Similarly, 15 in basketball. 15 in basketball means B plus C plus E plus F is equals to 15. 20 in cricket. D plus E plus F plus G is equals to 20. if these medals went to a total of 58, what is 58 given to you? 58 is the total medals, which means N of F union B union C. This value is 58. This value is N of F. This is N of B. This is N of C. And N of this one is all the values A plus B plus C plus D plus E plus F plus G. And only 3 got medals in all the 3 sports. All the 3 sports means that all the 3 circles overlap, which is your E portion. So N of F intersection B intersection C will be equals to 3, which is also equals to E value. Okay. Now we know we have to find how many received medals in exactly 2 of these sports. Now, when you say 2 of these sports, which means you have to calculate the value of B plus D plus F, because this is the region where you get only 2 sports overlap, only 2 circles overlap. Now we have a formula. We have a formula with us, N of F union B union C is equals to N of F plus N of B plus N of C plus N of F intersection B intersection C minus N of F intersection B minus N of B intersection C minus N of F intersection C. Now, out of these values are given to you. The underlying values are given to you. Here you have N of B intersection C. When you say B intersection F intersection B, you are considering B plus E region. This gives you B plus E. This gives you E plus F, and this gives you E plus D. So first we will calculate the addition of these regions, and we can subtract E thrice from over here and get the required result. Let's calculate, let's place the values. This is 58 is equals to 38 plus 15 plus 20 plus 3 minus N of F intersection B plus N of B intersection C plus N of F intersection C. So take the addition of these values, take 58 on the right hand side and subtract from it, and take all these values on the left hand side. So the minus sign will turn to be positive. So now here we can say that N of F intersection B plus N of F intersection C plus N of F in B intersection C will be equals to, after calculation, it comes down to be 18. Now we know that F intersection B, F and B, this is B plus E, B plus E, F plus C is D plus E, and this is F plus E. This is equals to 18. Now we also know that you have to take E on the right hand side, which has the value 3. So B plus D plus F will be equals to 18 minus 3 into D, 3 into E, which is 18 minus 3 into 9, 3 into 3. This is equals to 18 minus 9, which is equals to 9. So B plus D plus E plus F is equals to 9, which is equals to medals in exact students. How many received medals? So students who received medals in exactly 2 of the 3 sports. Students who received medals in exactly 2 of the 3 sports. That ends the miscellaneous examples. Thank you.